Okay, good day. So we will be having a discussion about mechanics and hydromechanics. So we will be focusing on Bernoulli's equation. So Bernoulli's equation, so it is the sum of the pressure energy, kinetic energy, and the potential energy. So as you can see in the formula, we have pressure energy P1, kinetic energy 1/2 P density times velocity 1 to the power of 2 plus the potential energy which is density times gravity times height. Okay, so Bernoulli's theorem describes the relationship between velocity, pressure, and elevation of a flowing fluid in a streamline. So as you can see in the equation, it is the sum of the pressure, kinetic, and potential energy of a fluid, which is constant in a streamline in steady flow. Okay, so that is the equation. So let's classify between pressure, potential, and kinetic energy. So as you can see in the GIF, so we have here they are the two orange robots are stretching the rubber band type of elastic type of material. So that is potential energy. And then when the violet or purple robot cut the wire or the rope or the elastic rope, then there is a movement of the rope, so that is kinetic energy. So potential energy is energy at rest, while kinetic energy is the energy in motion. Okay, in this GIF naman, so we can see that there is a swinging ball or something. So when the ball reaches its maximum swing, yung pinakadulo niya, so nagsa-stop siya. So nagkakaroon tayo ng potential energy. And then when it swings back downwards to the left or to the right, then it moves, then there is an increase of kinetic energy. Okay, dito naman, so roller coaster ride, pag nandun ka sa tuktok, so tumataas yung potential kasi nagsa-stop ka dun sa tuktok, and then pag bumagsak ka ulit, so nagmo-move ka, nagkakaroon tayo ng kinetic energy. So let's differentiate the different energies. Yung pressure energy is energy associated with the pressure of fluid in a system. So yung formula niya is pressure is equals to force over area. So some examples are the hydraulic systems, compressed air tanks. While the kinetic energy is energy associated with the motion of a fluid, so there is velocity. So its formula will be kinetic energy is equals to 1/2 times density times velocity to the power of 2. And some examples are the turbines, propeller for kinetic energy. So all moving equipments or machineries, so those do have kinetic energy. Next, we have the potential energy, which is energy associated with the elevation or position of a fluid relative to a reference point. So as you can see, these three types of energy is our topic is related to hydromechanics. So this potential energy is also connected to fluid. So the formula for potential energy is equals to density times gravity times height, or PGH, or Philippine General Hospital. Joke lang. While the examples, we have gravitational potential energy and elastic potential energy. Okay, so where do we apply the Bernoulli's principle or the conservation of energy? Siyempre, we are applying it in our coordinate teams. So in our love life daw, sabi nila. So conservation, so love is like conservation of energy. So if you give love to others, they receive it. But if they don't give it back to you, so yung life mo or yung love mo nagiging empty. At pag naubos ka, yun na, nasasaktan ka na nun. So kailangan somebody should give back the love that you give to that someone, to your special someone. Well, let's dig deeper. So in the maritime world, we can use the Bernoulli's principle in different kinds of equipments, especially like this one, ventilation systems. So we have a picture of a turbine, an exhaust blower, and a centrifugal blower. So Bernoulli's principle is used in designing ventilation systems on board ships and can optimize the ventilation to ensure proper air circulation and control of air quality within the ship's compartments. Next, we have fluid flow in pipes and pumps. So these are applications on board ships. Okay, for Bernoulli's principle, so we have orifice flow meter. So we can use the Bernoulli principle in this equipment. We have the Venturi meters. So this was discussed on our previous topics. Next, we have the different applications like understanding wind patterns. So there are ships nowadays that uses wind turbines or wind technology to harness this wind energy to have their ships minimize or optimize their minimize fuel consumption and optimize their ship. But we're using it on yachts and sailboats, but on bigger ships now they are currently using it nowadays. So hindi naman ganun karami, but there are some ships that uses wind, or they harness the wind energy for the propulsion of their ship. Next, we have hydraulic systems. So hydraulic systems on board ships such as steering mechanisms and cargo handling equipment rely on Bernoulli's principle for fluid flow analysis and energy conservation. So we have a picture on from the left top. So we have a steering gear system. So we have a steering wheel. We have a hatch cover hydraulic system on board ships. So we have different types of hydraulic systems on board ships that uses the Bernoulli's principle. So there are different machinery on board ship that uses the principles of conservation. First, we have diesel engines converting heat and chemical energy into mechanical energy. We have turbines. So at the top, we have a gas turbine, and at the bottom, we have a steam turbine. So they utilize the conservation of energy principle for the conversion of thermal energy into mechanical energy. Okay, next we have pumps and compressors. So we have pumps is used to transfer fluid from one point to another of higher energy level, while a compressor is the one that transfers or that compresses air or gases for conversion and use it in other forms of machineries on board. So pwede natin gamitin. We can use it for starting the engine. If we compressed air, we can use it for starting the engine, diesel engine, generators, or we can use it in our safety control systems, in our pneumatic control systems, and so much more. So compressors are used for gases. So since liquid is incompressible, so you cannot use compressors for liquids. Okay, next we have refrigeration systems. So refrigeration and air conditioning systems on board ships apply the principle of conservation of energy in heat exchange processes. So energy conservation principles are crucial for optimizing cooling systems and minimizing energy consumption, thereby using the Bernoulli's principle also. Next, oops, we'll go back. Next, we have boilers and heat exchangers. So utilizes the conservation of energy principle in heat transfer processes. So understanding energy conservation aids in optimizing steam generation, heating systems, and thermal efficiency. Next, we have propulsion systems. So application, ship propulsion systems including propellers, thrusters, and water jets apply energy conservation energy into thrust for propulsion. Okay. We also have electrical generators. Onboard ships rely on the conservation of energy principle for the conversion of mechanical energy into electrical energy. Uh, aids in optimizing power generation and distribution. We also have waste heat recovery systems on board, in which the waste from the exhaust of the engine, we can still use it to boil water from the economizer. That's for the right side GIF or picture or movie picture, and on the left, that's for the left side. While on the right side, we can see that there is a boiler, and then the smoke of the boiler is still used to preheat the economizer, so to preheat the feed water going through the boiler. So that's another type of waste heat recovery systems. Okay, lastly, we have wind and solar power systems. So the renewable energy systems such as wind turbines and solar panels apply the principle of conservation of energy for the efficient conversion of natural energy sources into electrical power contribution to sustainable energy practices. So it's a good start for, especially for big ships. So maybe they should also use solar power systems and wind power systems in their systems on board for electrical power and sustainable energy practices also. So let's try to solve problems by applying Bernoulli's equation. So scenario number 1. So let's start here. Air is flowing through a duct at point A. So the air speed is 20 meters per second and the pressure is 100 kilopascal. So at point B, which is 5 meters higher than point A, the pressure is 90 kilopascal. So calculate the speed of the air at point B if the density of air is 1.293 kilograms per cubic meter. So the given, we have velocity 1, which is 20 meters per second, pressure 1 of 100 kilopascals, the height of point B minus the height of point A is equals to 5 meters, pressure 2 of 90 kilopascals, and the density of air, which is 1.293 kilogram per cubic meter. So the required unit, or the required is the velocity 2. So let's try to solve. So as you can see in the solution, so we can use the formula for Bernoulli's principle, which is P1 plus 1/2 times density times V1 squared plus density times gravity times height 1 is equals to pressure 2 plus 1/2 times density times velocity 2 squared plus density of times gravity times height 2. So we can ignore the PGH formula since air is not affected by gravity. So we can remove the PGH, or the density times gravity times height 1 and density times gravity times height 2. So we have the formula P1 plus 1/2 times density times velocity squared. So if we want to solve for the required, which is V2, we will transfer V2 to the left side, while all the other units will be transferred to the right side. So V2 squared is equals to P1 minus P2 plus 1/2 PV1 squared times the 2 over density. So we can cross multiply, and we can transfer the other units. So since on the left side we have V2 squared, we should to cancel the squared, or the power of 2, we will have to square root both sides. So if we square root V2 squared, so cancel, the power of 2 will be cancelled, so the remaining value will be V2, which is equals to the square root of the P1 minus P2 plus 1/2 density times velocity 1 squared multiplied, or with close parenthesis, open and close parenthesis, times the 2 over P, open and close parenthesis. And then you should calculate the value first inside the bracket before using the square root. Okay, so as you can see, the value will be V2 is equals to 125.97 meters per second. Okay, that's for scenario 1. And then scenario 2 will be like this. So scenario 2, so what if the pressure 1 is equals to 3 bars, V1 is 4 meters per second, and H2 minus H1 is 3 meters, and P2 is 2.5 bars. So solve for V2. Same required. So V2 pa rin. So V2, we will be eliminating V2. Okay, so solution. Same solution. And since then we can ignore the height terms in this case, since the change in height from A to B is given as 3 meters. So the equation simplifies too, so we will have to ignore the PGH again. Okay, so the remaining formula will be P1 plus 1/2 PV1 squared equals P2 plus 1/2 PV2 squared. So we have to separate V2 from the other units. So transfer V2 to the left side, and then on the right side we will have P1 minus P2 plus 1/2 PV1 squared, open and close parenthesis, times 2 over P, since 1/2 P was transferred or was cross multiplied to the other side, so it will be converted into 2 over density. Okay, since V2 is powered, if squared is put to the power of 2, so we should eliminate the power of 2 by putting a square root. So we have to square root the V2 squared, so the squared or the power of 2 will be cancelled, while on the other side the square root will be retrieved. So square root of the whole P1 minus P2 plus 1/2 times density times V1 squared, open and close parenthesis, times 2 over P, open and close parenthesis. So we have to solve this one first inside the bracket before using the before using the square root. Okay, so if you can see, if you use your calculator, your answer will be V2 will be 10.77 meter per second. Okay, so also for scenario 3 we can still but in this scenario 3 the required will be the density. So what is the density of the density of the oil? So if you want to using the formula of Bernoulli, so to cancel or to solve or to get the required, so we will have to divide both sides by the density. So if you divide both sides by the density, almost all of the density will be, so out of 4 densities, 2 will be remained. So the one on the left side and one on the right side. So P1 over P plus 1/2 V1 squared plus GH1 is equals to P2 over P plus 1/2 V2 squared plus GH2. Okay. Next, we will have to put all the values with density on the left side, while the remaining values without density will be put on the right side rather. So all the values with density will be put on the left side, while all the values without density will be put on the right side. And then after that, we will have to cross multiply. So cross multiply so that density will be the remaining value on the left side while the other remaining values will be on the right side. So P1 minus P2 divided by the 1/2 times V1 squared plus GH1 minus 1/2 V2 squared minus GH2. Okay, with open and close parentheses. So first, calculate the open and close parentheses, so the value inside the parentheses. So calculate first before dividing, or you can use your calculator directly. So your answer will be, what's your answer? Oops, so there is no answer in my slide, so you can compute it by yourself on your calculators. Okay, so the solution or the formula was already given, so you can answer it by putting the values on their respective places. Okay, so that's it for all the sample problems for Bernoulli's equation. Okay, now we will be we have to explain the value of liquid passing any section per second in pipe flow. So according to Bernoulli's equation, the volume of liquid passing through any section, well, we will have to discuss this maybe on our next video. So for the part 2, since we already have 20 minutes of time, so we will discuss this on our part 2. So I hope you'll have learned something about Bernoulli's principle, and see you on our part 2 video of this PowerPoint presentation. Bye!